Today we will talking about the neural radiant field, or we can call in short NeRF. My name is Taran Hamusik, and this is my self-running project. So let's start it. Before we going to talking about NeRF, we will be talking about what is the 3D model generation. So in concept and basically, 3D model generation is turning image into model. We collecting multiple data from the surrounding object that we want, and we implement it into the 3D object in 3D space. Sounds simple, but what is really useful? Some of these methods we already use in the game industry, AR, VR, film, filmmaking industry, architecture, or even in some engineering field to creating a realistic digital twin to enchanting the user immersive. So before that, we were talking about some briefly history of it. Pre-model form the image is not a very new thing, but it's not really old. It happened around the early 20th century from the concept of the photogrammetry that they want to creating a model from the image using multiple image in multiple surrounding to creating a one object in 3D space. But on that time, they still have a lot of limitation and some of this process still developing to this day. So the traditional method that they used then before is called photogrammetry. In short, it's they're taking a lot of image and connecting it edge to edge. Like we have the first photo on one angle, second photo on the side angle, and more and more and more. Then they turn that data of image into the point cloud, reconstruct it and make it more dense point cloud of the image. Then when we have some point, they're using another algorithm to connecting the point into the mesh or the tree object that we know. And lastly, they adding the texture from the image onto it. It still have some limitation that it have some complex and take a lot of time to produce one object. So now we introducing into the NeRF. NeRF is some kind of new technology. It happened in around in 2020, representing how to use the deep learning or neural network into creating a model of three objects. So how it works? NeRF are not working like a photogrammetry. They're not connecting edge to edge, but they use the deep learning to predict and creating a point or dot of an image on that point to make it similar to the image that create. Like the light point on this point on this point, try to creating make it replicate the image. So when they have multiple view, multiple point, they try to create, and it's become a new model from the different method. Like in the picture, we have a two point of view of the of the object, and one point represent on this one point represent on this one, and they cross it and calculating into another point. So they do it multiple times in every point of the object. Make it have a new object that try to replicate the light and from the image. So if sound right is a good that they not try to creating from the scratch, from the point cloud, from the 2D that have a colorless and put texture from like before, but it still have some limitation and advantage. So let's talk about advantage first. It have a high photorealistic accuracy. They using deep learning to calculate and predicting the point on the model to creating things. like the reflection transparency is replicant that smoothly and photorealism is compatible to neural storage uh, and it have a flexibility for resolution rendering because now we have a deep learning for prediction. It's more like we don't have to get the most highest quality of image to produce it for now. Because in we using photogrammetry, we need to find the right angle and right angle, right time, right light environment, and the single set of image to make it more accuracy. But for this one, we don't have to using much accuracy than that. But we still have some limitation. First is some of training. It need to have a lot of data than the traditional way. It require it requiring some time to process because it's using a time to learn and time to predicting, using more of the processing GPU or sometime it has much higher cost for now. And now it still have a lot of limitation that we can apply to some program of engineering like CAD because it's still young and new technology for now. And some of the hard point or ex- hard point of the image, it still have some problem with that because it's still lack of researching of this technology. So in the real world use case, we still not have much use case, but we they are also have some for entertainment, realistic digital creation set, virtual tourist, historical site, robotic enchantment, environment mapping, medical imaging, or more. Sometimes I also see some real work that they using this method to scanning some of the historical site and is processing really good and realistic photorealism result in a not so long time for the result that when we comparing to the traditional way to do that in photogrammetry, it cut off many steps of that because they don't have to turn a lot of image to point cloud first and to the mesh and set texture back. They creating the point with some light in real on that time by one step. So talk about the future and direction of this. We will say some real-time rendering on application, handle some of the dynamic scene, some hard point and explicit geometry for some direction, and generalized model for adaptation to some scene. Because this model are the quick and very new technologies. So it still need to have time for develop and still have bright future for learning. Even no, as we know, the photogrammetry has been making like 25 years ago and is still some of the main feature that we use nowadays. And this one is only 5 years old for this technology, and we don't have much research on that yet. But it still have bright future for this field, for deep learning and for the model creation from 3D model. Thank you for listening and goodbye.